Okay, this is 3.2 Polynomial Inequalities in one variable. And our objective today will be to solve and graph polynomial inequalities in one variable. So we're going to have, inequalities in terms of x. Okay, so first problem. Solve the cubic trinomial x to the third minus 2x squared minus 3x, and that is less than 0. All right, so now every time you're asked to do something like this, you're thinking, is this factorable? Is this cubic trinomial factorable? And if it is, we just use what we call, if p of x is factorable, we're going to use a sign graph to answer this question. And I'll show you that if we can factor it. All right, so let's see if we can factor. All right, well, now I have three terms right here, and this is cubic, but do you notice that there is a common factor in each term? Because what? Every term has an x in it. There's no constant term there. So I'm going to factor the x out, and there's no common coefficient, so I'm just going to go the x right there. And then I think to myself, distributive property. X times what is x to the third? Well, that would be an x squared. X times what is negative 2x squared? That would be a negative 2x. And then x times what is negative 3x? That would be a negative 3. Now, I'm hoping this quadratic factor is factorable. So let's see if we can do that. All right. So, well, x squared, I'd have an x and an x. And then I need a product of negative 3 and a sum of negative 2. Well, that's pretty easy. Can I go minus 3 and then plus 1? Because negative 3 times 1 is negative 3. And negative 3 plus 1 is negative 2. So there's my three factors. If p of x is factorable, use a sign graph. So that's just a number line. And now I'm going to use each factor to come up with my roots. All right, so my first factor is an x, meaning the root would be 0. That's where this polynomial would cross the x-axis if I graphed it. And then the next factor is x minus 3, so that's going to give me a root of 3. Let's put that over there. And the final factor is x plus 1, giving me a root of negative 1. I'll put that right there. Okay, now, this is then going to be a graph on a number line, and I look at my inequality, less than 0. That means the dots on the number line will be open dots, because this cubic cannot equal 0. So I'm going to have a dot at my first factor, 0, at my second factor, 3, and at my third factor, negative 1. And now, here's how we use the sign graph now to answer this question. When is x to the third minus 2x squared minus 3x less than 0? Well, just pick an interval here between our open dots. Okay? Now, I can choose any x value less than negative 1. All right? Maybe negative 2. And all I do is plug that into my factors to see if these three factors will give me a positive or a negative output. So if I use an x equals negative 2, well, that would be negative, and then negative 2 minus 3 more, negative, and then negative 2 plus 1, that's also negative. So if x equals negative 2, or any number in this interval, I have a negative times a negative times a negative, which is a negative. Put a minus above that. Now, the next interval is between negative 1 and 0. All right, and by the way, I already know what this is, because isn't negative 1 a single root? X plus 1 is the factor, that's a single root. So that means my sign of this cubic would have to change. So if I'm negative to the left of a single root, I must be positive to the right. All right, and then the 0 is also a single root. All right, so if I'm positive to the left of the single root, I have got to be negative to the right. And the 3 is my third single root. So if I am negative to the left of that 3, I'm going to have to be positive to the right. And we are now almost done. Now I look at my inequality again. This cubic is less than 0. So what am I looking for here? All right, the negative. Let me go back. I was pointing and looking at the wrong thing. So this cubic right here, I'm looking at the factored form. Focus on that, less than 0. That's means I'm looking for the negatives here in my intervals. So in this interval to the left of -1, all right, I'm always negative. Okay, and then, I can do the inequality now, or I can move on and look for another negative. Do you see this interval between 0 and 3? Also negative. Looks like I went to my inequality here. But what is the inequality for that graph right there? Well, isn't x less than that -1? And now look at for the other negative right here, and that's this interval right there. So that's going to be, well, begin with the 0. And 0 is less than, that's an open dot, less than what? My variable x. And x is, open dot again, less than what number? 3. And there's my solutions right there. So we have not only a graph, but inequalities. Okay, so this is a great little activity here. What is the sign of the quantity x minus 1 squared for x less than 1 and then for x greater than 1? So to do this activity, I would do a little sign graph again. So there's my sign graph, and if I look at the factor x minus 1, that implies I would have a root of 1. So there's my 1 on my 1 hash mark right there. And now look at the inequalities. We're talking less than, so I'll go ahead and put an open dot right here on that 1. Okay, now let's look at the interval to the left of that x equals 1 for x less than 1. So I'm just put a little arrow right there. And now what I do is I choose what's called a test point. I can pick any number I want that is to the left of this 1. How about 0? And if I plug a 0 into this expression right here, don't I have -1 squared, which is positive? And also, if I was graphing the quadratic y equals x minus 1 quantity squared, wouldn't this root we have right here, wouldn't that be a double root? So that means that on the other side, I would also have to be positive. So for x less than 1, well, I am positive, and for x greater than 1, I am positive. So positive in both intervals. Okay? Now, excuse me, explain why x minus 1 quantity squared does not change sign at x equals 1. Well, we use that to come up with the positive in this interval right here. It is because that 1 is a double root. Because 1 is a double root. So, what is the sign of, well, it looks like they're just adding a few more factors here. -2 x plus 3 quantity squared times x minus 1 quantity squared for the interval -3 is less than x and x is less than 1. Well, it looks like in this cubic, I have one more factor of x plus 3. So that means I have a root of -3. So let's put -3 over here somewhere. All right. And again, look at my intervals are all open right there. So I'm going to go open dot. Okay. Now, what's going on over here then? Okay, I'm looking in this interval from -3 to 1 exclusive. That's this interval right here. So again, what is the sign? Well, again, the sign didn't change right there, or did it? Oh yeah, I have a negative out front. All right, so let's double check this then. Let's pick a number now between -3 and 1. How about 0 again? All right, and plug it into my factors. So I'm negative, I'm positive, and I'm positive. What is a negative times a positive times a positive? That'd be negative. So I'm now negative right there. So there we go. If I'm negative in this interval, so what is the sign of -2 x plus 3 squared times x minus 1 squared for -3 is less than x and x is less than 1? We're negative. My sign graph shows me that right there. Now, what is the sign of -2 x plus 3 squared times x minus 1 squared for x greater than 1? This is the same cubic, so I'm talking about this interval right here, x greater than 1. So let's think about this root right here. All right, well, the factor is x minus 1 squared that gave me the root of 1. And because that factor is being squared, it's a double root, so that means now I have to be negative on this side too. Negative there. So for x greater than 1, I am negative. Negative. Explain why this expression does not change sign at x equals 1. And again, just like above, 1 is a double root. Because 1 is a double root. Pretty cool activity. Okay, so let's put the concept of the sign graph to work right now. We're going to solve the quartic inequality, or excuse me, that's a cubic inequality. X squared minus 1 times the quantity x minus 4 squared is greater than or equal to 0. And if we can factor this, we will be able to use a sign graph, and this will be really easy. So if p of x is factorable, use a sign graph. So this looks factored, but it's not completely factored yet. So let's see. Do you see that x squared minus 1 right there? Isn't that the difference of squares? And won't that give me a factor of x plus 1 times x minus 1? X plus 1 times x minus 1. And then the third factor, which is being squared, is x minus 4 quantity squared. All right, it's now completely factored. Sign graph. And the first factor of x plus 1 gives me a root of negative 1. The second factor of x minus 1 gives me a root of 1. And the third factor of x minus 4, which is being squared, gives me a double root of 4. Remember, this is going to be a double root. All right, so now I look at my inequality. Do you see the equals greater than or equal to? So my dots will be solid for the equals. And now let's pick an interval. Now, I usually choose 0 when I can, but this one I'm going to work left to right. So I started over here. All right, so I'm going to use an x value that is in the interval less than negative 1. So how about I just use a negative 2? Negative 2 plus 1, negative. Negative 2 minus 1, also negative. And this quantity squared will be positive, so I see a negative times a positive, which is positive. Now, I don't have to do any more crunching of numbers if I understand my roots. That negative 1 is a single root because of the factor x plus 1. So that means the sign will have to change. So if I'm positive to the left, I will be negative to the right. Now the 1, what kind of root is that? That's also a single root. So if I'm negative to the left of a single root, I must be positive to the right. And then finally, the 4. The 4 is a double root. So over here, with this being a double root, if I'm positive to the left of the double root, I must be positive to the right. And there we go. I'm ready to answer this question with both a graph and inequalities. I'm looking for greater than or equal to 0 right here. So I'm looking for these pluses. So see this plus right here? I'm going to have this interval. And that is what? Let's go ahead and write the inequality that represents that. So that would be x is less than or equal to negative 1. X is solid dot, arrow to the left, less than or equal to what? The negative 1. And then let's go over here, negative, positive the rest of the way, here and here. So let's just do our graph like that. And isn't that nothing more than x is solid dot to the right, greater than or equal to positive 1. There you have it. Okay. Oh, look at this. Same scenario, but this is not a polynomial. This is a rational expression right here, all right? So that adds one more little thing to think about. It's factored, so we can still use the sign graph. And we're going to plot the zeros of the numerator and the denominator on our sign graph. So the first factor is x plus 2, giving me a root or a 0 of negative 2. Okay. Now the next factor is x minus 5 being squared, so that's going to give me a root of positive 5, and that's going to be a double root. And then I'm dividing by x minus 4. That's not going to give me a root. That's going to give me a discontinuity, because what number can we not divide by? 0. So in this situation, x cannot equal 4. So I'm going to put a 4 on my sign graph right here. All right. But that, I'm going to actually put an open dot right there, because x cannot equal 4. So let's think about all our dots though now. All right. Do you guys see the less than or equal to? All right. I see equals. So at my first root of -2, I'm going to go a solid dot. At my next double root of +5, I'm going to go solid dot again. But remember, this is not a root, this is a discontinuity. So at x equals 4, I'm going to have to put an open dot. All right, now let's go to work. Test points again. All right, and I usually like to start at 0, but sometimes I'll go left to right. It doesn't matter. So I'm going left to right here. So -2, I need an x to the left of -2. How about I go -3? -3 plus 2 is negative. -3 minus 5, quantity squared, would be positive. So I have a negative times a positive. And what's my divisor? -3 minus 4 more, that's going to be negative. So I see negative times positive divided by negative, positive. There you go. Now, what kind of root is -2? It's a single root, because the factor is x plus 2. So I'm going to have to go from positive to negative. Now, the 4 is not a root, it's a discontinuity. So I have to check either this interval or this interval. So it looks like I'm going to go ahead and throw the fraction in there. That's okay. How about I call that like 4.5? 4.5 plus 2, positive. 4.5 minus 5 squared, positive. 4.5 minus 4, also positive. Everything's positive. That's a plus. And then 5, what kind of root is 5? Isn't that a double root? X minus 5 squared. So that means the sign would stay the same. So if I'm plus to the left of my double root, I'm going to be plus to the right. Now, my inequality, less than or equal to. Aren't I looking for the minuses? And I only see a minus in this interval between -2 and +4. Right there. So let's write out that inequality. So wouldn't that be -2 and solid dot, arrow to the right. So -2 is less than or equal to x. That's any real number in this interval. And x has to be open dot less than the 4. And there you have it. Solved with a graph and a double inequality. Oh, I almost missed that. All right. Remember, this is less than or equal to 0. So you see that 5 right there? That's not an interval, but this rational expression is equal to 0 when x equals 5. So you better add that to your answers too. And I just made a very common mistake right there. I'm sorry I got sloppy. All right. Use a calculator to solve 2x to the third plus x squared minus 8x plus 3 is greater than 0. All right. Now this is a cubic with 4 terms, so sometimes we can solve this with grouping, but that's not going to happen here. We might even do the rational root theorem, but if I remember right, this only has one rational root, so grouping or the rational root theorem won't give me everything I need. I'm going to have some irrational roots, so I'm going to use a calculator. You might try grouping or rational roots, but neither will work here. Okay, so what I did is I got my calculator out and I put this cubic on the calculator, and I did this on a standard Windows to see if I could see everything I need. And I can, but I want to blow this up a little bit for you all. So I changed my window. And I look at the x values here at my roots, so I'm just going to go -3 to 3. So I changed my window from -3 to 3. I didn't do anything with anything else because now I'm just going to go a zoom fit. And my calculator will give me the perfect y interval for the x interval of -3, 3. And there's the graph right there. Now this I can see a little better because I want to make a point right here. Use a calculator to solve when this cubic is greater than 0. So I'm looking for the intervals where the graph is above the x-axis. So on the x-axis there, on the x-axis there, on the x-axis there, and here's my intervals that I'm going to look for right here, and then it's positive also over here. There we go. So if I can use my calculator to find this x value, and this x value, I'm ready to answer this question. In fact, I can set it up right now. All right, so this is going to be some number is less than x and x is less than that number. And this is going to be x is greater than that number. So there we go. Now let's just use our calculator and find those x values. So I took my calculator and I did second calc 0, and the first x value on the left is approximately negative 2.4. So I can put that in there right now if I wanted. I did. So negative 2.4 is less than x and x is less than, and then I used my calculator to find this x value. So I did my second calc 0 and I got approximately 0.4. So there's my first interval right there. Negative 2.4 is less than x and x is less than 0.4. Now I just need this x value right there, or on this graph right there. And I found that, and that was my one rational root right there, 1.5 or 3 over 2. So I'm going to say x is greater than, and since I use decimals here, I'll just go 1.5, 1.5. Oh, that's a great problem. And your homework is 3.2, do 1 through 27 odd. Okay, as I was looking at the homework problems, I took a look at this number 23, and I just thought, wow, I want to make a video presentation of this problem. So this is a little bonus coverage. Do yourselves a favor. Put this into your notebook. It is a great problem and a great opportunity to apply the rational root theorem. Again, picture what we're talking about. Solving a quartic inequality. I mean, right there, that's intimidating. There aren't too many people on the street that can go out and solve this thing. But you guys have the rational root theorem, and with that, you can solve just about anything. All right, rational root theorem, exciting. So let's think. P, based upon the rational root theorem, has to be a factor of your constant, negative 1. That implies that P could only be positive 1 or negative 1. Now Q, based upon the rational root theorem, would have to be a factor of your leading coefficient. So what are the factors of 4? Plus or minus 1, plus or minus 2, or plus or minus 4. Now, I usually don't write out all of my possible P over Qs, but there aren't that many here. So I'll go ahead and write them all out. Who knows what we're going to need? So I could have plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 1 over plus or minus 2 would be plus or minus 1/2. And plus or minus 1 over plus or minus 4 would be plus or minus 1/4. Those are all the possible rational roots of the quartic equation. Okay, so, and usually I do direct substitution, but I'm just going with ones and negative ones. But you know what? I'm hoping one of those are going to work, and then I'm going to need the quotient polynomial to continue. So I'm going to go like this. All right, let's put a 1 in the box. And now we're doing shotgun methods. So let's list our coefficients of our original polynomial. Our quartic coefficient is a 4. Our cubic coefficient is negative 4. Our quadratic coefficient is negative 3. And our linear coefficient is 4. Our constant is negative 1. And now the shotgun method of synthetic substitution. Let's bring the 4 down and go 4 times 1 is 4. Minus that 4 above would be a 0. 0 times 1 is 0. Minus the 3 above would be a negative 3. Negative 3 times 1 is negative 3. plus this 4 would be a 1. And 1 times 1 is 1, minus 1, and look at that. There's my 0 right there. Now, that's exciting. Remember too, 1 might be a double root, so we better check 1 again. But let's put 1 into the quotient polynomial now. We are done with these. Yeah, I'm excited too. Here's the 1, and now I bring down the 4. 4 times 1 is 4, plus 0 is 4. 4 times 1 is 4, minus 3 is 1. And 1 times 1 is 1. Oh, but that's a plus 1, so that's a 2. So 1 is not a double root, so I still only have 1 root. Kind of sad here. Well, let's check the negative 1 then. And now remember, I'm not using these coefficients. I'm still using the coefficients above for my original quotient polynomial. So negative 1 in the box, and bring down the 4. 4 times negative 1 is negative 4 plus 0 is negative 4. Negative 4 times negative 1 is 4. Minus a 3 is a 1. And then 1 times negative 1 is negative 1, but plus that 1, and that's a 0. So I have my second root. It's negative 1. Yeah, I'm excited again. And now, these are the coefficients of a quadratic, and we're experts at solving quadratics. In fact, this one, I think, may be factorable, because we have 4x squared minus 4x plus 1. Set that equal to 0. Let's see if we can solve this. Well, 4x squared, I'm going to try a 2x and a 2x. It could be a 4x and an x, but I think 2x and 2x. And now I have a product of 1, but look at the negative 4x there. That means, aren't I going to have a negative 1 and a negative 1? Now let's make sure that works. 2x times 2x, 4x squared. And then I have a negative 2x and another negative 2x for a negative 4x. And then negative 1 times negative 1 is 1. There we go, right there. I have my other root, and that's going to be a double root. So that implies, now think about this, 2x minus 1 would have to equal 0. That means my root would be positive 1/2. 1/2 is a double root. And let's see, I have a root of 1, I have a root of negative 1, and then I have a double root of 1/2. This is a quartic. There's only going to be 4 roots, so that's all of them. P of x is factorable. Let's use a sign graph. So now I hope you guys know the factors right here. Look at your first root. It's 1. Doesn't that give me a factor of x minus 1? Look at your second root. It's negative 1. So that would give me a factor of x plus 1. And then my third root is the 1/2, which is going to give me those factors of 2x minus 1 and 2x minus 1, or 2x minus 1, but again, double root, that factor's got to be squared. There it is, factored form. So let's use our sign graph. You bet. All right, so let's write down our roots, and because of the greater than, I'm going to put open dots on my roots. So a factor of x minus 1 gives me a root of 1, open dot. A factor of x plus 1 gives me a root of negative 1, open dot. And a factor of 2x minus 1 gives me a root of 1/2, and that is going to be a double root. So let's squeeze an open dot right in here. Or excuse me, where am I at here? 1/2 right in here. Be careful, Gibbons. And that, remember, is a double root. Now, let's choose a test point. Okay? Now, I'll just probably go over here on the left. Yeah, I did. All right, so I'm going to use negative 2 as a test point. And I'm going to plug negative 2 into the factored form of my polynomial. So negative 2 minus 1 more is negative. Negative 2 plus 1 is negative, and any quantity squared is positive. So where was I at again? I forgot already. A negative times a positive is positive. All right, now in this interval, well, I could do the 0 and direct substitution, but you know me. Isn't that negative 1 a single root? So doesn't the sign have to change? I already know that has to be negative. And then the 1/2, That was a double root. So in this little interval right here between 1/2 and 1, if 1/2 is a double root and I'm negative to the left, I have to be negative to the right. And then what's the 1? Well, I have a factor of x minus 1. That makes this a single root. So over here, I am going to have to change signs. So if I'm negative to the left of a single root, I better be positive to the right. Greater than 0. Aren't I looking for the positives? This interval. Okay, and that would be what? X is less than negative 1. And then the other positive interval is right here. And that is x is greater than 1. And there are your two solutions. All right, so we have a graph of our solutions and our two inequalities right there. That's a great problem. Okay. Thank you very much.